Hello, this is the next section of the Code with Altino's Facilitators program, and this video recording is specifically for teachers who will be delivering the program in their classrooms. Let's get started. So the learning outcomes for this module are for teachers to understand the learning design of the Code with Altino curriculum and how it can help you teach technology to your students, even if you are not technology inclined or have any experience in computer programming. Secondly, for teachers to understand how the Code with Altino curriculum links to the New South Wales syllabus, NESA, and also the Australian Digital Curriculum, ACARA. And also to understand classroom environment issues with Altino. So firstly, a quick summary of the Code with Altino curriculum. It has been designed to have easy to follow modules, just as this module has been set up, and I'm reading it from the presentation. It's easy to follow. It's like follow the bouncing ball. It's been designed for non-tech savvy teachers in mind. We haven't designed it for teachers who have a coding experience background. We've specifically designed this as step-by-step, follow the bouncing ball for non-tech savvy teachers. We have tailored programs for each school year and for each NESA stage in New South Wales, and also student ability in the case of high school. The modules can also be teacher-driven or self-driven. So with teacher-driven, it's in presentation format, in PowerPoint and also PDF format, like this module is, and you can present to the class and drive the teaching. Or alternatively, if you have more advanced students, they can follow the modules and exercises themselves, for example, on their own iPads or their own computers. All of the modules are available at codewithaltino.com.au. So the learning design of the curriculum is based on the principle of intentional design. You'll see this term used in this book. It's a good book. It's from America. It's called Learning Transformed. And if you want to learn a little bit more about innovative design and designing curriculum for the future, I do recommend you have a look at this book. So my background, my name's Tony, and I have quite extensive background in change management in corporate life, and I also have experience in implementing technology solutions into corporate life. And it is very similar to this situation where, for instance, you are expected as a teacher, for example, to teach coding or technology in your class. However, you don't have any background. And we're in the same situation as this in change management. So, for instance, new software would be introduced to the company, and while the managers didn't have any experience with the technology at all, their staff were still expected to use the software in terms of how the company wanted them to use it. So I'm using my background to design how this process can work in your school. So, for example, managers, non-technical managers, educate their teams in the knowledge, skills and attitudes, or you may know this as competencies, to support technology change. So let's have a look at the approach that we used in corporate. This is where the team managers act as facilitators of learning of their own staff. Usually they are non-tech savvy. So what we did as the change management consulting firm is to design a new curriculum and provide that to the team managers. And then the team managers basically trained their own staff using the curriculum. So let's have a look at the school side. Likewise in schools, teachers facilitate the learning of the students. There's nothing unusual about that. And again, they may be non-tech savvy. Again, this is the new curriculum we've designed and provided for you, but we've added one additional thing because of the school environment and because of the coding education context, is we also recommend that teachers assign digital leaders for each class, and in many cases these digital leaders will actually be the students, a couple of students that you nominate in the class to help you with the technology. Because what you'll find going through this curriculum is the students actually pick up the technology much faster than you, particularly as they're going step by step through the exercises. And your more advanced students will pick things up really quickly, and they can actually help to guide you and your students through the technology parts of this program So basically we have design where the teachers are teaching the students are teaching the students, and the students are teaching the teachers. And it's really a very innovative and very powerful way of teaching technology in your classroom. So this is a learning design that I've set up for this curriculum. I call it COBOT learning design. And again, it's based on processes that I've previously used in change management in companies. COBOT stands for Competency-Based Outcomes with Technologies. So this curriculum has been designed under the principles of COBOT, and I've tailored it to schools. So what are the principles of COBOT? Competencies and outcomes are the focus of learning. So notice at the beginning of each of these modules for the Facilitators program, before every module, I've stated what the learning outcomes are for that module. Just as important it is for you to talk the students through the learning outcomes for each module so they know what they're in for and what they're expected to focus on. Different types of learning activities are used. We're going to go through the learning activity icons, and I'll show you them. Outcomes are also linked to educational key learning areas, for example, in digital curriculum and STEM. Learning outcomes are evaluated after each class or project. Obviously, this is, you don't have to do this. It's not compulsory. However, good learning and good change happens when you evaluate the learning outcomes. All the materials are there ready for you if you want to go through that process and assess the students' progress as they go through each module. There is opportunities for students to reflect on what they have learned after each module, and the reason for that is adult learning principles and any type of learning. The evidence proves that you actually have to take the time and opportunity to reflect on what you've learned. Otherwise, you forget. So it's just basically a reflection exercise at the end of each module to say, okay, what have we learned? How can we apply that? And there is also a continued focus on developing work-based skills, and this is where my experience comes in as the curriculum designer to say, okay, all this STEM learning, this is how it can be applied in real life. So each program, in this case, this is the Scratch curriculum for primary school, is broken up into different modules. Just as this Facilitators program is in different modules, so is each curriculum. So here is the Scratch curriculum. It's separated into beginner and advanced. What you'll actually find is if your students progress from Scratch, let's say to Python, the modules are very similar, and we set up that design deliberately so that once they go through a development pathway, they've already learned so much in that first curriculum so that by the time they move to the next one, they're already familiar with the structure, they're already familiar with the application, they're already familiar with the meaning of the programming, and then they just move straight on to different syntax or a different language. So this is a deliberate setup. So you'll see that each module has a code, and we'll talk through that. Each module has its own name, and then you can even divide it into sub-phases if you like. So for instance, the Scratch curriculum, Python, C Arduino, all start with the basic robot functions. And as you go through these modules with the students, they'll learn each of these functions, and they'll actually see how the programming programs those functions. Then they are then prerequisites to coding basics of loops, operators, conditional statements. And once you get some familiarity and exposure to computer programming language, you will see that these are coding basics for any type of language, and really excellent learning for the students. And then we move to more advanced coding, and this is where, for instance, once you get to the end of the beginners phase, you may need to touch base, for example, with me and say, Tony, we've got up to this stage, just a little bit not quite sure about how to move on to the next. Can you offer some advice or in terms of moving on to the next phase? So please, at any time, if you get to a module and you're not quite sure, ask the person, the technology person in your school or the change person in your school. And if you feel that you need a little bit more assistance, please don't hesitate to contact me, because I really want you to move successfully through this program and not feel as if that you have to stop for any reason. particularly if you don't have any confidence to progress on to the next module. And you may actually find that, for example, moving on to the advanced section. We've tried to make this curriculum step by step, but it doesn't mean that in real life, when you're dealing with real students, that you're not going to have any issues. So please, as you know as a teacher, there is no such thing as a stupid question. So please get into contact with us. We're here to help. We're here to help you help the students. So that's just showing the structure of each of the programs. Next, as we mentioned before, there are learning outcomes mentioned at the beginning of every module. So for example, as you can see down the bottom, this is from the Use Data Variables module, and it's from the Scratch program, because you can see that the letter F, which stands for Foundation or Scratch. And then F10 actually is referring to the number module. So number 10 was using data variables. So let's have a look back at that. So F10 is using data variables. So we can tell by the footer that's using data variables. And number 2 is actually for New South Wales customers only, for New South Wales schools only. 2 is referring to Stage 2 NESA. If you're in a non-New South Wales state, know that Stage 2 is Year 3 or Year 4, and Stage 3 is Year 5 or Year 6. So see here the learning outcome, it says F10.3. That's really just for Years 5 and 6, and maybe a little bit more advanced for 3rd grade and 4th grade, or Years 3 and 4. So here is an example again of the learning outcomes at the beginning of this module. It's a really good idea every time before you start a module, simply just to talk through the learning outcomes at the beginning, just as I have in this Facilitators program. At the beginning of every module is also a page letting you know what the teacher's resources are. The students don't need to see this. This is for you to check before delivering any of the modules. Generally, obviously, your Altino robots. 1 per 2 students is ideal learning. We talk about that later. You may be in a situation for budget reasons or for any other reason that you have less, not in a situation where you can have 1 robot between 2 students. That's okay. We'll talk about that too. So for instance, you may have set up a STEM room or something like that. Tablets, each student needs a tablet or iPhone. I'm going to talk through all the resources needed in a separate module. It's the last module of this Facilitators program, and it's called Resources. So I do recommend that you read that, but this is for the benefit of this module. It's basically to show you that you're told which resources to use for each module before you start delivering, so you can be well prepared. Every module also has a structure that looks like this. So back to F10 module again, using data variables. On the left-hand side are the coding and robotics skills, or the technology side, and the right-hand side are the STEM topics. So we encourage you to use your student digital leaders to help with the coding and robotics skills, or to help other students who might be having issues in working out how to use the coding for these different exercises. This is probably one of the most complicated structures we have, because it's data variables and it's in 2 sections. So this is the second section. Notice here that also with dots means Stage 3 only, and that's the reason why I wanted to show you this one, to show that where you've got dots around the yellow, that is for Stage 3 only, or Years 5 and 6, and where you have dots around the grey box, that's where you may want to have a digital leader give a demonstration first. So before we mention learning activity icons, this is embedded into the design. And as you know, students learn in different ways. Some learn by just by talking, some learn by doing, some learn by watching videos. This curriculum basically uses different ways of learning. You'll see the lecture. What I'm going to do now is to switch on the highlighter. So I'm just going to switch on the highlighter, and you may choose to do this too. Pointer options, laser pointer. So here is the lecture icon. You've seen this a lot in the Facilitators program because it is basically imparting knowledge onto you as the teacher in terms of how this program works. A stimulus question is basically a question that you pose to the class. If there is a specific black and white answer that's correct, we will provide that answer for you. Demo means a demonstration. So for instance, that may be you, or it may be one of the students' digital leaders showing the class how to set up a set of blocks initially. Activity is the main learning activity used in the program. Different for the Facilitator's program, where it's been a lot of lecture and a lot of me talking. Totally different to how the Code with Altino program has been set up. You'll find that at least 60% of the program is activity based. And what that means is, yes, there are lectures for you, demonstrations, setting up the learning, but then the students have a go. And this is the STEM learning. They're given examples. We also provide the answers to them. And it's up to you as a teacher to assess the level of the students at the time. Do you want to show them the answer at the time, or do you want them to learn through it first? And you can make that call as you go. And that's the reason why we've set this the program up as a PowerPoint presentation or PDF, because you may choose not to show the answers, and that's up to you. You can easily show the answers or not. Obviously, when you're starting to teach, I would show the answers. And then the students can look up at the screen and basically just follow what's required. And you'll get used to that. Fascinating fact. This is something that's not really all that important, but interesting to know. And we've already come across an example of that. This icon basically is referring to showing a video resource. We've done that in the Facilitators program. We've also embedded a lot of video resources from YouTube to help with the learning. Here is a creative thinking option. This is where some collaborative problem solving comes into play. At the end of some of these modules, you'll see this icon. This means that it is set homework that you may choose to give to your students. And then if there is a homework set, at the beginning of the next one module will be a review of their homework. The little avocado guy is basically just a food for thought. It's not really compulsory learning, but it's just a little bit of, it's exactly what it is, food for thought. We mentioned at the beginning of this module that it's good to reflect, and it helps students learn when they're given opportunity to reflect on their learning. This is part of the end of every module, and then there are some games involved too. So here are some more icons. They're really relevant only more to high school. So for instance, a science icon, it's a science concept. There's an icon for a mathematics concept. And then those technology electives really are only for New South Wales NESA mapping, with the digital technologies, technology elective, engineered systems and material technology. So you can easily identify if so for instance, there are exercises that are specifically only to the engineered systems elective. So here is an example of just a basic demonstration. This is in the second module, I think, of the Scratch program. Where are the lights on a robot? So you can say, now we're going to use the Scratch to program Altino's lights. You can use that to show the students where the lights are positioned on Altino. And see how it has quite specific about you talking about where the position of the lights are on Altino. And then the next page actually is an activity for the students to control the lights. So the activity is turn on the forward and reverse light on Altino by programming in Scratch language. And then it actually gives the actual blocks the students can use to help their learning. And again, as I mentioned, it's up to you each time they run through an exercise. Do you want to show them the answers straight off, or using PowerPoint or the PDF program, you may choose not to reveal that until some of them have actually gone through the exercise and done some learning and some step-by-step problem solving. It's up to you how you use it. Here is an example of, I'm not going to read it, but here is an example of some STEM learning that you can talk through. Again, it's a lecture icon, so you can just talk through this, and this is part of the learning for students to go, instead of just learning about sensors, and they think, well, so what? Well, you're actually teaching them about things that they see in everyday life and how they can actually change the environment around them. So let's have a look at another block. This is from the sounds module, which is getting a little bit more advanced stage of Scratch. So this is, I'm not going to read this, but here is another example, and this is showing the final set of blocks for the students. And then again, here is a stimulus question. What's a real life example of this programming? In this instance, we actually give the answer for you after you've had the discussion with the class. Here is an example from the C Arduino. This is text-based programming. Again, it's exactly the same activity as in Scratch, but it's using a different language. I know it's a C Arduino program because it has the letter C-A-R. It's number 2, module 2. And number 4 means that it's stage 4 in New South Wales, NESA language, or years 7 and 8. In the C Arduino program, the coding is written on the left for the students to write on their coding, and the explanation is on the right so that they know what they're doing, and you can help explain what each of the levels are. And then by the time they've gone through so many exercises, this is how they learn all about the programming language in C. And again, another stimulus question. How did they change the code from the control rear motor exercise? So they're not just doing the activity, you're also making them think about what they're doing and what they're changing. So the learning outcomes for the Code with Altino curriculum for your students is to provide students with engaging real-life projects with Altino the robot to learn how to code in a step-by-step fashion, from foundation skills such as Scratch to more advanced programming languages such as Python, C Arduino. Understand how coding skills apply to real-life situations, as we've just seen with the beep in the car. Deliver the STEM components of NESA and ACARA in an Australian curriculum. Deliver the main points of the Australian digital curriculum. Learn about how digital technology can help your students learn more about non-STEM subjects, and to develop future job-based skills of coding and robotics sought by employers. So that's the more longer bullet points to do with why would we even teach the Code with Altino curriculum in our school. That's the reason. The actual Scratch program, the learning outcomes are to complete a series of foundation projects to set up a strong learning foundation in coding principles and robotics applications so that other curriculum objectives can be achieved. The reason for calling them foundation projects is really for the benefit of high school, where in New South Wales, where NESA has stipulated text-based programming, and really Scratch is about setting up a foundation of learning to then progress into the text-based programming. And then, of course, projects are also linking to national curriculum capabilities, for example, communication, and you'll see examples of that in the mapping. So I've already talked through a little bit about how the modules are labelled. Each module is labelled with a code. So anything that's in the Scratch program is labelled F. Anything in Python is labelled PYT. C Arduino is CAR, etc. Each Code with Altino module is also labelled with a suffix code to show the relevant grade or NESA stage the activity is relevant to. I've already talked about that as an example. So the suffix 1, 2, 3, 4 applies to the grade. Numbers are also used for each module for each language. For example, Scratch program modules are labelled F1 to F23. Sorry, that's a mistake. There's not 23 modules, there's a lot less than that. Therefore, if an exercise has F23 in the footer, you know that it is the second module of the Scratch program, F for foundation, 2 for second module, and is relevant to stage 3, grades 5 and 6 only, not grades 3 and 4. That is really only relevant to primary schools because we've differentiated the program between years 3 and 4 and years 5 and 6. So the curriculum has been designed in a flexible way. So I've put the demo icon here because I'm hoping that I've demonstrated this. So self-learning for advanced students. So for instance, if you've got advanced students who just want to learn the program themselves, they can do that. Because it's modular, you can have different facilitators or different teachers for the same course. So for instance, you may deliver the first 3 modules of Scratch and then another teacher comes along and delivers the next few modules. You can explore opportunities for teachers and or students to design new projects to cover non-STEAM parts of the curriculum. And the curriculum has been designed in PowerPoint, as I'm showing you now, so you can cut, copy and paste activities in digital format. So for instance, you can run your programs as they are, or however you might choose to do some preparation and cut out content that you think isn't relevant to your students, or indeed you may want to add activities that you've included. It's up to you how you use it. This is just a different way of how the curriculum has been mapped to education standards. So anything in green is about the ACARA or Australian standards. Anything in yellow is NESA, New South Wales. So for instance, technology mandatory and elective, science and technology and mathematics. Anything in blue relates to STEM. So in terms of New South Wales, for instance, we've got the foundation, we have the science and technology, and we have mathematics, and that's your STEM and that's your digital technologies, for example. So the code without each project in the curriculum has been mapped to the following educational standards. Firstly, NESA, and that's the link to the NESA website. If you're primary school, it's science and technology, and if it's high school, it's technology mandatory. If you're in a non-New South Wales state, it's the National Curriculum ACARA. So we have been analysed these standards and we've mapped each module of the Code with Altino program to these standards. So let's have just a quick look at it now. So I'm clicking into the Code with Altino website, and let's say I'm in high school, or I'm going to be teaching high school. And I'm already logged in. So I'm going to be teaching the Scratch Fast Track program. What I'm doing here, remember, is looking at the mapping. So here is all of the modules, the curriculum summary, and you've got your mapping down here. So it says for New South Wales skills, that shows you how you can load everything into your NESA program builder. But let's have a look at how the Fast Track Scratch program has been mapped to the NESA Stage 4 Technology Mandatory and STEM syllabus. And here it is. So we don't need to go through the first few pages. So for instance, this is your first module and the mapping. It has the learning outcomes. It shows the where we've got the outcomes that are linked to technology mandatory. Here are some links to the engineered systems. You've got general capabilities from ACARA, and every module is the same. It's showing you the exact mapping that you can use. So there you have it. So just to summarise, we've seen how the code without the curriculum is mapped on NESA and National Curriculum Standards. It has been designed to bring STEM to life and is based on collaborative project-based work, encourages self-learning for advanced students, turns a so what into oh, so that's why, that is, applies the student's learning to real life, and allows customisation to both NESA stages and current student class capabilities. And the curriculum has been developed using the innovative and proven COBOT learning methodology. So how do you access the Code with Altino curriculum? Only members of the website can access the curriculum. Membership is free to all staff of purchasing schools or organisations. Access requires a licence number. So your school purchaser of Altino will have been given a licence number. You do need to give us that to access. You'll have a username and password that you cannot pass on to anyone else. You can, if you like, pass on your username and password to your current students for their own learning in your own classroom, but nobody else. So how do you apply? You go to the website, you use the orange button on the home page to request membership, and you will need an Altino license number. So I'll just spend a minute showing you that. You can jump ahead if you've already gone through this process. Here is where you request member access if you don't have a login. If you already have a login, you can just click the member login. Use orange. That's just a pop-up. So you click in here for your member login. Once you've logged in, you can click onto the high school tab. You can click onto the primary school tab and you've got access to the entire website. So back to classroom environment. You can transform, with Altino, your classrooms into active learning environments. For example, you can encourage problem solving by setting up the mazes, and we do have those available. You may have got them in your Altino package. You encourage teamwork by students programming Altino to sing in a chorus, for example, by using loops. And you can engage students in leadership by having them demonstrate to other students what they can do with Altino. So did you know you can look at the classroom resources page at the beginning of each module? It says, does this module require blocks? If no, this means your students can work comfortably at their own desks and program Altino, as there is no movement involved. However, for Project Dev 3, Make a Robot Sing may be a bit noisy for other classrooms, but have a look on this page where it says you need 10 blocks or mazes. That suggests that the robots are going to be moving around, so you may want to either move to a different classroom to run this module, or you can simply just run Altino on the floor of your classroom by using the mazes. It's up to you. We recommend for each class or project that you randomly assign teams of 2, which means 1 robot to 2 students. If they're working on their own or not watching the screen for the exercises, each pair will need 2 iPads or tablets. Sorry, 1 iPad or tablet, 1 student to do the coding on Scratch, while the other uses their iPad to view the exercise blocks. So many coding challenges, for example with Code Camp, they have 2 random students working together to solve coding challenges. In this way, different partners solve problems together and therefore help to build each other's confidence. This helps as coding tasks become more difficult. So this snippet was from 2 girls working together at a girls' code camp. We got a new challenge to tackle, as well as a new randomly assigned partner. At first, each assignment brought a fresh wave of anxiety, even though my first experience with Carla had been so positive. I felt forced to provide my intelligence and coding skills to yet another classmate every time. Each pair would chug along at one computer, taking turns on the keyboard. So there really was no hiding if I didn't know how to solve a problem or if I was confused. We break down larger tasks into small codable bits, just as we had done with the slot machine challenge, and then talk through how to do each step together. So in summary, you really have groups of 2 students. So each of that pair of students has their 1 iPad or 1 PC, and then they've got the robot working together. Now, if you've got a package where you haven't purchased enough robots for 1 robot between 2 students, that's okay too. We talk about that in the resources module of the Facilitators program. The students will learn them more by observation rather than doing, simply because each student isn't get as many opportunities in the actual programming, but that's okay too, and we'll talk about that then. Okay, that's the end of this module. Thanks very much.